Hello, everyone, and welcome to our science series. Thank you so much for coming today. You are in for a real treat. I would like to introduce Dr. Peter Zale. He is Director of Conservation Horticulture and Collections at Longwood Gardens, where he leads plant exploration, collections, conservation, and breeding programs. He holds a master's degree and a Ph.D. in plant breeding and genetics from the Ohio State University, and has participated in more than 30 plant exploration expeditions across the U.S., East Asia, Central Asia, the Caucasus, Mexico, and Equatorial Africa. His work at Longwood and in his personal life focuses especially on building a comprehensive conservation horticulture program for native U.S. orchids and beyond. In 2024, he received the Philip E. Keenan Award for his contributions to native orchid conservation. Dr. Peter Zale. Thank you.
Thank you, Jessica. No pressure. Okay. Well, welcome everyone to the gardens. Where we can all enjoy this very well-deserved sunny day that we're having. So I'll try not to take too long so you can go out and enjoy the gardens. But today I'm going to talk about a subject that is very near and dear to me, as Jessica mentioned, not only from a professional perspective, but from a personal standpoint as well. And that is how horticulture is used to promote growth, awareness, and really the resiliency of rare plants from around the world. So horticulture, I think, as you walk the gardens here, everywhere around you are the efforts of horticultural practices that help define the gardens. You can see in the image here, it involves many things. Horticulture is a multifaceted, many-splendored discipline that involves not only just growing plants, but propagating plants, collecting seeds, growing plants in our laboratory, and what I'm going to talk about today, cracking the code, how we use certain techniques, certain knowledge we have, and apply it to these plants for which we don't know a lot about in terms of propagating and growing. So if we look at this, horticulture is the science and art of growing plants. I'm being a bit facetious because we often say it's the art and science of growing plants, but I am a scientist, and so that's what I'm going to start with. And this circle that you see here represents some of the practices that we're involved in, some of the things that we do to help get plants into the gardens, but also make sure that they are remaining and healthy in the wild. So you saw the video. We talked about the 4 pillars of science, and one of them, and the main one that I'm involved with, is conserve. And so if we look at a little bit more closely at this, what we're really saying there is that we're using horticulture, applying horticultural knowledge to conserving the plants that need it the most. If we think about all the 350 or 400,000 plants we have on the planet, some are very common, some are not so common. And so horticulturists can play a role in understanding not only why some plants are rare, but also improving their health, bringing them to gardens, and various things that we can do to help create a more solid future for them. So I'm going to take this one step further, and I'm going to talk about conservation horticulture. And this is really taking all of these horticultural practices, which I'm going to go into, and applying them to those plants that need it the most. It could be orchids, like you see there in the image on the right. It could be rare plants here in Pennsylvania in the other image, such as the trailing wolfsbane or white monkshood. So I guess the first question is, how do we know which plants are rare, right? There are so many types of plants on the planet. How do we know where to start? And fortunately, there's a very dedicated group of people working at institutions around the world that help us define this. And I've listed some of them here. CITES, you might have heard of. CITES is an acronym for the Convention on the International Trade of Endangered Species of Flora and Fauna. It is a global framework that really helps to protect those plants that need it the most. There's different appendices that list plants in order of priority in terms of rarity. And at the top of the list are some things you might expect: carnivorous plants, cacti, and orchids, which I'm going to talk about quite a bit today. Other organizations, such as the International Union for the Conservation of Nature, they do this practice called red listing. So that's basically a concerted effort to look at all plants around the world over time and determine what is their status. Are they globally secure? Are they vulnerable? Are they critically endangered? Or worse yet, are they extinct? And so this is a very important practice in helping organize global thinking about how we put our efforts into the plants that need it the most. Last but not least, there's two organizations here in the US. We have the Endangered Species Act, which is a federal program, lots of plants on that list. And I think most importantly are our state heritage programs. And here in Pennsylvania, we have a robust natural heritage program that employs botanists whose job it is to scour the state and basically update the status of rare plants and determine, are plants becoming more rare? Are they becoming more common? So there's a lot of work that goes into that. And we draw on all of these different organizations and institutions to help us define where we're going to work, in addition to our own knowledge and intuition as well. So how does this work? Let's have an example. My favorite plant is the Kentucky lady slipper, also known as the southern lady slipper. I've been growing it for 30 years of my life. Cypripedium kentuckiense, so it is an orchid. So when you look at the CITES list, every single orchid, and bear in mind, orchids represent about 8 to 10% of all the plants on the planet. Every single orchid, it is on Appendix 1 or Appendix 2. That means every orchid, from a global perspective, is considered endangered or threatened in some way. So we know right off the bat, if you're working with an orchid, it probably needs help. We know that a species like Cypripedium kentuckiense is globally vulnerable. The IUCN says it's globally vulnerable. There's only about 5,000 plants left in the wild, and I can tell you from my own experience and from my many partners in state heritage programs that is declining precipitously. So we think about this, and we kind of, this helps us determine which plants we're going to work on. If you look at that range map in the bottom right there, you see all those counties highlighted in yellow. If that plant was secure and stable, all of those would be highlighted in green. But the fact that they're highlighted in yellow tells us that everywhere where it grows, it's in trouble. So let's look a little closer at orchids. You know, everybody enjoys the orchid room over there, just to the west of us. And orchids are really poster children for rare species conservation. As I mentioned, every orchid is on the CITES list. The IUCN says basically half of all the orchids in the world are declining rapidly. And our state heritage programs say the same thing. I don't know if you know, but here in Pennsylvania, we have at least historically, about 60 species of orchids. That makes Pennsylvania, if you can believe this or not, the 5th most orchid diverse state in the United States. We have more native orchids in Pennsylvania than Hawaii and California combined. So we have this very rich flora here, but it's disappearing. And in some cases, some of these species have already disappeared. They're extirpated, meaning that they're extinct from our state. So this is alarming. And for me, it creates an incredible sense of urgency. And so when I started here at Longwood about 11 years ago, there was an idea to enter the world of plant conservation. And we looked at, all of these different institutions that I've just mentioned, how they've defined what needs to be worked on, and also looked at, what is important to our identity here at Longwood. It turns out that orchids are our largest collection. The 150 or 200 that you see on display in there is a small fraction of the 2,200 types of orchids we have in our collection, some of which have been here for a century. So we wanted to take this kernel of information, this interest, and grow it into something else. And we started this conservation program focused on our native orchids. In order to do this, we have to have partnerships. So with some of those institutions I mentioned a little bit earlier, but others as well, we collect seeds. We have a laboratory behind the conservatory here where we can take the dust-like seeds of orchids and learn how to propagate them, and I'll talk more about that. And that allows us to generate plants that you might be able to see out in the living collections, but then also plants we can use for restoration and conservation as well. And I think it's really important that we mention our partners. And this is a snapshot of many of the people that we work with. You can see them here. I think most notably, the Pennsylvania Plant Conservation Alliance, which is housed by the Pennsylvania DCNR. is one of our main partners, and they work across the state really looking at the plants here in Pennsylvania that need the most help. And we work with lots of people. And, you know, I'm up here, I get the opportunity to be up here and to talk to you about all of this, but I'm not doing all of this work in a vacuum. Right, so we've got a robust team of dedicated people here that are also working to help us conserve plants. And you can see some of them here, not only our staff that we have here, but also our volunteers as well. We have volunteers that do all kinds of things here at Longwood, and I can't sing their praises enough. So all of this work, no matter what we're doing with any kind of rare plant, is really based on the partnerships, the collaborations that we have, and the people that we have here at Longwood helping to do the work. So I'm going to go back to orchids a little bit. I really love orchids. I never miss an opportunity to talk about them. So I want to talk about orchid seeds. So orchids have seeds like no other plants. So in the image there, you can see a penny, right? Also an endangered species, apparently. But next to it, that speck there is an orchid seed, all right? A seed of one of our native ladies' tresses. So orchids have these tiny dust-like seeds. They tend to be about 6 millimeters long at their largest size and about 0.05 millimeters long at their smallest size. At 0.05 millimeters, you can't even see it. Like, we literally can't even see it. It's that small. That represents a new challenge for collecting, but that's a different story. The reason that orchid seeds are so small is because, unlike most seeds, they've lost their endosperm. So one of the things that defines flowering plants is what's called double fertilization. And in one part, that's creating the seedling embryo, and in the other part is creating this nutrient-rich packet that seedling has to germinate and to grow, and gives it energy before it can photosynthesize and make its own energy. Orchids don't have that. So what they've done is they have enlisted fungi to do the work for them. And essentially what they do is they fall into the soil or on a tree or wherever it is that they're growing. They imbibe with water, they hydrate, and if the right fungus is there, it basically interacts with that seed, and that seed germinates, and it can colonize that fungus in its cells and basically use it as a food source, right? So essentially, orchids are parasitizing fungi. We often think about that relationship the other way, but orchids are kind of like the practical jokesters of the orchid, of the plant kingdom. So they've done a lot of things to really utilize all the things in the environment around them. So the thing about orchid seeds, about 75 years ago, it was figured out how to germinate them in a lab without fungus. So basically making a medium in a sterile environment that can serve as a proxy for this fungus. But it turns out that many of them are still really difficult to germinate. And we want to know why that is. So this is where I'm going to start talking about cracking the code, all right? And largely what it comes down to is seed dormancy. So when you buy a packet of seeds, whether it's tomatoes or zinnias or whatever it is, at the store, you're buying a packet of dormant seeds, right? And so in order to get them to break dormancy, typically we add warmth and moisture, right? And for many plants, that works perfectly fine. But for many other types of plants, it's much more complicated. And that's where dormancy comes in. Dormancy is a critical factor, and there are many types of dormancy: physiological dormancy, physical dormancy, chemical dormancy, all these different things, all these different cues potentially in the environment that any seed might need to germinate. And so part of what we do is try to figure this out. It's a bit like a detective story. It's a bit of a puzzle. We're trying to figure out exactly what this plant needs based on context clues of species that it might be related to, but also where it might be growing in the wild. So one of the ways that we have learned to overcome dormancy in orchids is to harvest the seeds before they're ready to go. And so we call this immature seed propagation. And you can see the lady slipper orchid there in the photo that's taken here in Chester County. That's one of our most charismatic native plants that we have. You can see it here in the gardens in May in the hillside garden. And basically, this information came from Kew Gardens. In England in the 1980s, they have a yellow lady slipper there. There was one left in the wild. They thought, well, okay, we want to propagate it and put more back, so they hand-pollinated it. They got the seeds. They put the seeds in the lab, and they thought, okay, we're good to go. We're done. The problem is none of the seeds germinated, and this lasted for years. They could not figure out what to do, but they got a tip from a surgeon in Sweden who just happened to be propagating orchids for fun, and he said, you should harvest the seeds before they're mature. And it turns out that this was a major breakthrough, right? This simple thing, but it was something that nobody had really ever thought of. And so we thought, well, okay, maybe we can take this information and we can apply it here. And that's exactly what we did. So this shows the process where we hand-pollinate flowers, we harvest the seeds, we sow them in our lab, we grow them on, and then maybe 3 to 6 years later, with lady slipper orchids, you can get a display like this. So it can still take a long time to get the flowers. And it turns out that this Cypripedium kentuckiense, which I already mentioned as being this really rare plant, turns out that it's really easy to grow in cultivation. And it's interesting that many orchids are very rare in the wild, but respond readily to horticultural practices and to cultivation as well. So if you want to see the Kentucky lady slipper, there are many of them now, all propagated here in our lab using this technique, and they flower in the latter part of May over in Pierce's Woods. So we thought, well, this is really great. Like, we took this information, we used it, it worked, we had proof of concept, and we were really excited about it, but we also know that many of our other native orchids are in this category of being difficult or even impossible to grow. And in particular, the genus Platanthera. And you can see in the image there, Platanthera peramina, the purple fringeless orchid. Most of these are called fringed orchids. This one is a bit of a rebel. So the purple fringeless orchid is a PA native species, and it's kind of a quirky species because it can appear in a place one year and there can be hundreds in flower, and then the next year there can be 1 or 2 or 0. And it really varies from year to year how many you have. It also turns out that this one, despite many attempts using the mature seeds as we harvest them when they naturally ripen, didn't work. We couldn't get it to work. We tried all kinds of things. We gave them cold treatment, we gave them fluctuating temperatures, we put them in the light, we put them in the dark, we tried all these things, and it didn't work. So we thought, well, let's see if we can take this concept of using the immature seeds and successfully propagate this plant. So we did a study, and when you're talking about harvesting immature seeds of orchids, timing is everything, right? So with lady slippers, we know 50 to 55 days after pollination is when you harvest the seeds. I mean, that window it's a very discrete window. But we know that when you go to other types of orchids, that window can change. Like that same practice for a tropical epiphytic cattleya, like you'll see in the orchid house, it's more like 210 days. So what we needed to do for Platanthera was figure out that timing. So we set up a study. You can see the steps here. We harvested the seeds basically every week, starting 2 weeks after the flowers were pollinated. We put them into petri dishes in our lab. And then we charted seedling development. We waited for them to germinate, and that's what that third picture is. Those are what orchid seedlings look like. They're very tiny. And then we basically grew them on from that point, and it worked really well. So basically, once we did this experimental process, we defined this window of propagation at about 18 to 29 days after pollination. So that's great. It worked. Now we're able to propagate this plant. And not only could we do it that one time, we're able to repeat it again and again, and also with species that are related to this orchid. So now we have this knowledge, this original research that we've done, which we're hoping to publish. Now we can apply it to plants that need it, but we can also apply it to things like Platanthera leucophila, which you see there, which is a federally endangered species that has been very resistant in terms of propagating from mature seeds. So it's a very simple idea, but it's very powerful, and it was just something that nobody had looked at before. And I would say that, the research we do here is very applied, and it's very pragmatic, and we really want to look at real-world problems, horticultural problems, and then apply those so that we can have a tangible outcome. And so, okay, we germinated the seeds, we defined the window, we know that it works, now we have to grow the plants. And if you have ever grown native orchids, you might have seen or read, well, native orchids are impossible to grow, don't even try. Well, in some cases that might be true. There are many other hard to grow plants, but in some cases it's not true. And so we did a study a little while ago to basically look at the best practices for growing these orchids. We knew we could grow them in the lab, and so what you see here is a paper we published where we actually grew plants under sterile conditions in our lab. We planted them into different potting mixes, and then we gave half of them fungi, and half of them didn't get fungi. And most of the time at Longwood, we're trying to get rid of fungi, and probably as a home gardener, you might be trying to do this too. But in this case, fungi can potentially really help the orchids. And it was an interesting thing. We had to figure out how to grow the fungus, right? We're so used to growing plants. We put them in pots, we choose the potting mix, all these different things. But when it comes to growing fungus, there's a lot of different ways you can do it. And this slide illustrates some of those. You can grow it on millet, you can grow it on potato broth. But what we ultimately ended up doing was growing them on these things called sorborods, which are these little cellulose plugs. And then we could conveniently take one of those and put them into the pot and see not only if the fungus was growing in there, but if that fungus was then in turn benefiting that orchid. And I left one figure in here. I hope it's okay. I just wanted to show, so this is what the experiment looks like, okay? And it turns out adding fungus to orchids helps them grow. And that chart on the right shows that. So on the far right-hand side, that line going up says, yes, you add fungus to these, survivorship, quality of plants increases. On the left-hand side, they survived, but it wasn't nearly as good. So this was something of a breakthrough, right? Typically, people will try to add orchid seeds to fungi and get the seeds to germinate them in the lab, and that kind of works, but this is taking it and adding the fungus at a different step. It seems very complicated, but at the end of the day, we really just want to grow the plants. And the cool thing is, we still have some of these plants growing. So these are platantheras growing in our bog. We planted them out in 2021, and we wanted to see what they would do. So here's what they look like in 2022. They got a little bit better. In 2023, we saw a huge jump in performance. Please ignore all those rainbow-colored tags in there. And so plants started improving over time, and 2024 they got better. 2025 really looking good, and really, they keep getting better and better. And the thing that's interesting is that these plants are showing a growth response that you never see in the wild. Typically, these platantheras just have one stem year to year. The same plant will come up and flower, maybe not flower. These plants are forming clumps and growing vegetatively and increasing like crazy. So not only did adding this fungus help us grow the plants and get them established at first, but it also seems to have had an effect further on down the line. So if you're interested in seeing these, if you weren't aware that there are orchids in Pennsylvania and maybe you're intrigued, I highly recommend to go to our idea garden this summer. Typically known as a vegetable garden, and there's some perennial garden over there and some other things, but the gardeners over there this last year put this beautiful bog garden in there. And many of the fringed orchids, fringeless orchids, they grow in wetland environments, often with carnivorous plants like pitcher plants and sundews and Venus flytraps and things like that. So the gardeners over there tried to replicate this environment so that you can see this snapshot of a habitat that we have as close by as the New Jersey pine barrens, but really kind of stretching all the way through the coast of the southeastern United States. So highly recommended to go over there. It was just planted last year, looked really good. This year, it should be even better. So that's all I'm going to say about orchids. I'm going to switch gears a little bit because I want to look more broadly at the flora of Pennsylvania. And so Pennsylvania has a lot of rare plants. I'm going to go into that, but there's 3 species in particular that we've been working on here. Polemonium van Bruntii, the bog's Jacob ladder, or bog Jacob's ladder. We've written some blogs about that. It's a very rare plant in Pennsylvania. Tall, beautiful, blue-flowered plant. Only 5 known locations in the state. This one in the middle, Aconitum reclinatum, is the trailing monkshood or trailing wolfsbane. It's either white monkshood, trailing wolfsbane. I never can get those quite right. That is a plant that only basically grows in 2 places in Pennsylvania. And then the last one is Taenidia montana, which is a very rare plant in the carrot family, for which almost nothing is known. So these 3 species are listed species. They're S1, which means in Pennsylvania there's 7 or fewer populations in the state, so very, very rare. But I just want to step back for a minute and look at the flora of Pennsylvania. And I recently came into this information. I was shocked. So there's 3,586 documented plants in the state, okay? Only 2,140 of those are native. So when you look outside, only 60% of the flora that you see is actually native. And so much of what we're seeing, especially so here in southern Chester County, are invasive species, right? So that's shocking. You should be shocked when you hear that, right? I mean, we're kind of in ground zero for invasive species here in the eastern US. So to me, that really drives the sense of urgency for working with those plants that are the most rare. If we look at those 2,140 native plants, 350, or about 15% of those, are considered endangered or threatened in our state. So we have a lot of work to do. And Taenidia montana is one of those plants. Here it is right here on the right. It is a modest plant in the wild, grows in very dry places. It does have somewhat showy flowers. You can see it there. I hope by bringing it to cultivation we can make it a bit more robust. But you can see the range map. See those yellow counties there, right? It only occurs in one county in Pennsylvania, Bedford County, which you've driven through if you've ever driven across the Pennsylvania Turnpike. Happens to be a botanical paradise for many reasons. So this species is threatened throughout its range. It only occurs in 4 states. And so through our work with the Pennsylvania Plant Conservation Alliance, they said we have got to do something to protect this species. A couple years ago, we started a seed bank here to conserve seeds of these plants, and we started working on this right away, but we also wanted to see if we could propagate it. And when we looked into doing that, it turns out nobody has done this. There's no information out there, right? I couldn't find anything. If you happen to know about this, I'd love to talk to you afterwards. But there's really nothing out there. And Apiaceae, the carrot family, can be really tricky. I just saw a report of a species from North Carolina that they wanted to reintroduce to the state. They had to keep the seeds underwater and give them different temperature cycles for 2 years to get them to germinate. And I thought, oh my gosh, like how long is this going to take? To complicate this, we only had 15 seeds the first year. So this is a plant that not only is rare in the wild, but it does a disappearing act. So usually in the middle of summer, for whatever reason, and nobody knows why, the plants come up, they flower, they look good, they look like they're setting seed, and then something happens and they're not there anymore. So collecting the seeds is really tricky. And basically, what we did was, you can gather context clues from related species. So there happens to be another Taenidia called Taenidia integerrima, and there's a tiny bit of information about that basically says these plants the seeds have physiological dormancy, which means that they need a cold, wet period in order to germinate. And so that's what we did. We took our 15 very valuable seeds, we put them into one of these boxes that you see here, which we call germination boxes. They're actually made to store honeycomb from bees, but what we do is we take them, we put that blue paper in there, we soak it with water, and then we put seeds on that, and then we put that in our fridge. And then in that way, we can watch what's going on. We can make observations the whole time because we want to see what's happening. It's one thing to put them in a pot in the soil and kind of cross your fingers and wait, and that can work, but in this case, with so few seeds, we put them in that box because we wanted to see what was happening. And we're still learning. So of those 15 seeds, we got 8 of them to germinate, and basically it was, we put them in for 3 months, brought them out for a few days, waited for something to happen, nothing happened, put them back in the fridge for a month, brought them back out, and that finally got a few of them to germinate. So we did confirm that there probably is physiological dormancy, but now we need to do a broader test. Just this last year, we were able to collect, I think, a couple hundred seeds of this species, so we're going to try to do a little bit more. And my hope is that one day you can see the species growing out in the garden and we can talk to you about it. So we're always working on projects like this, and right here in Pennsylvania with our native flora, but also around the world as well. Part of what I get to do here is travel the world and look for places where we can take this horticultural expertise and apply it to the plants that need it the most. You can see I haven't been to all those places, I've been to a lot of them, but this program has been going on, plant exploration, for about 70 years. So Longwood staff have traversed the globe looking for plants. Now we traverse the globe looking for conservation stories that we can help with. A lot of our work has been happening most recently in southern Tanzania. This is Mbeya Peak, which is in the southern highlands of Tanzania, where there happens to be a lot of orchids. And the orchids there grow in the ground. They're terrestrial orchids, and they make these big starchy roots that are harvested and made into a food called chikanda. It's kind of like, I've not had it, but it's likened to, and the Swahili word is polony, which I think is a translation of bologna, because it basically, they take these tubers and the peanuts and some spices, smash them all up and make them into a loaf and serve it that way. And what used to be sort of a special occasion food in rural parts of Zambia and Tanzania is now becoming like a commonplace part of the cuisine. So there's demand for it throughout Zambia, which means that because all of it is made from orchids harvested from the wild, the orchids are being eaten to death. So we wanted to go over there and see if we could still find them, put eyes on them, just kind of see what the status of these orchids is in the wild. So Mbeya Peak is very special because there's a few orchids that only occur on Mbeya Peak. And in 2005, one of them, Disa walteri, was relocated for the first time in probably, I think, 60 years. And they published a paper about it, the botanists that found it, and they said, you know, there's only 20 left. You know, this is critically endangered. Something needs to be done. So 20 years and one day after they were there, we went up there and we found Disa walteri growing there. There it was. But unfortunately, only 7 of them. Only 7 plants. Perhaps the last 7 plants, you know, left in the wild. We looked for it in the other places where it was supposed to grow, but we couldn't find it. I mean, the landscape of southern Tanzania has been altered dramatically by people. So not only did we find that, but we found these other rare orchids growing up there as well that only occur in 1 or 2 places, have only been seen a handful of times since they were described 100 years ago. And so I'm telling you this because, you know, this is where we're going next. We've developed this expertise with propagating orchids, using immature seed, using these different methods to propagate our native orchids, which are quite different from tropical epiphytes, but it turns out that these Tanzanian terrestrial orchids might respond and are responding very similarly to our native orchids. So I hope I can tell you more about that one day. I'm going to switch gears a little bit. I've been talking a lot about seeds and cracking the code with seed dormancy and that kind of thing, but there's other ways we crack the code too. And last year we went to Tajikistan, which is in Central Asia. You can see the map of the country there. All those pins are places that we went. You can see my colleagues and myself there. That is a walnut tree that we're standing in, an ancient walnut tree, the same walnut tree that produces the walnuts that we eat. But we were really there to look for different kinds of bulbs or geophytes, right? We think of tulip displays here and narcissus and all these different types of bulbs, but Central Asia is really the bulb belt, right? So tulips and corydalus and irises, like you see here, are all a part of the flora. And so we wanted to go over there to find these species and make collections of the seeds to bring them back here to the gardens to hopefully improve or not improve, but build upon the wonderful bulb displays that we have here in the spring. One of the plants that my colleagues who are from Sweden and England were very interested in was this one called Dionysia involucrata. Not a bulb at all. It is a cliff-dwelling, basically dwarf shrub that grows out of the cracks of cliffs. It's hard to see in the photo on the right. I hope you can see it there, but it grows in very treacherous places, literally in vertical slopes. And so most of the plants that were growing there, I mean, you could not get to them without being a very skilled rock climber, but some of them were down low. And colleagues from the Gothenburg Botanical Garden I was with, they have the largest collection of Dionysia, most of which are native to Iran, in cultivation, but they didn't have this one. And Dionysias don't really like to set seeds. We weren't there at the right time for seed. The plants were flowering. So Johan, my friend and colleague, said, I'm going to try to take cuttings in the field and carry them back with me, and we'll see what happens. And so we hadn't done this before. So he basically put on a field propagation masterclass for us. And you can see the plant there. That Dionysia in the image, we happen to be with the man from Sweden who wrote the treatment of the genus, so probably the foremost world expert on Dionysia. He estimated that plant in the image to probably be between 80 and 100 years old. And it looks crazy. Well, we obviously harvested a plant, but what we did with this was take the cuttings, but then also make herbarium specimens too, so that these are represented as documents or as specimens in permanent herbarium collections as well. But you can see Johan on the right-hand side there taking these cuttings, these tiny cuttings, a centimeter in length, carefully trimming the leaves. And you can see our Tajik partners there, they couldn't get enough of it. I think in this country, we kind of take horticulture for granted, right? It's a pastime. You can go to, a box store, you can buy potting mix, you can do all that, you can get seeds, all these things. It's not like that in a lot of other countries. There's still a lot of need for horticultural knowledge, and how it translates into bringing these plants from the wild into cultivation. So Johan collected these cuttings. You can see him sticking them there. And the thing is, this was at the beginning of our trip. We were there for 3 weeks. So he not only had to carefully prepare these cuttings, he then had to carry them around for 2 more weeks and make sure that they were never in a hot car, never in the sun, never drying out, never bothered. I mean, it was like he was carrying his child with him. Everywhere we went, he had this box of cuttings. But it paid off. And so this is what they look like, and you can see the one on the right after he got back to Sweden. They had rooted and now are starting to grow. And in case you're wondering what Dionysias look like, they are truly incredible plants in cultivation. This is the collection at Gothenburg. So when we think about alpine plants, if you're a rock garden person, they often talk about alpine cushions, these tight, hard cushions. They get covered with flowers. There isn't a genus of plants that does that better than Dionysia, and you can see them here. If you ever have the chance to go to Gothenburg in Sweden, other than Longwood, I would say that Gothenburg Botanical Garden is my favorite garden in the world. Absolutely incredible, not just for the Dionysia, but the best bulb or geophyte collection anywhere in the world. So, rounding it out, some take-home messages. So, I hope I've demonstrated plant propagation, horticultural skill, all these things we do are crucial and critical to conserving plants here, not only in Pennsylvania, but all around the world. And that knowledge, we take that knowledge with us wherever we go, and we try to educate people where we can. For many of the plants, this code still needs to be cracked, right? So there's still a lot of plants out there. You can collect the seeds. You still have to learn how to germinate them. And, there's a lot of great references about how to do that, but we don't know about everything. So there's still a lot to learn. And we do a lot of, like I said, research to try to figure this out, not only to, increase our own scientific expertise, but to share knowledge with others as well. So lots of great stories like this. I hope we can share more of them with you. Thank you very much for coming. Enjoy the gardens.